Hello, pre-calculus student. This video is for chapter 4.6 for solve exponential and log equation. And we are in the second part, which is dealing with solving log equation. So what is a log equation? A log equation you have an unknown, but the unknown is inside a log, like this, and then you can have another log, and the answer is another uh, 7, for example. So we are interested in solving this type. In chapter 4.3, we actually have solved. So these are where the unknown is trapped inside a log, and we want to do it. Um, first things we want to, before we talk about how to, is what not to. So please do not combine like term outside and inside. So do not think of, oh, I have a plus 5, let's do minus 5, and then it will be log x and then solve it. No, we don't do that. This is not valid. So don't minus 5 and minus 5 like this. Things inside a log cannot be combined with things outside the log. That's the first thing. You cannot divide log by divide log also. You can cancel log by either using exponent, which is the inverse function, because inverse means you can cancel it, right? The inverse and exponent cancel each other. But you can only do it when you have one log on one side and one log the other side. So another things you cannot do would be like log x and then log another x, right? X plus 1, oh, is equal to log 7. We would say, oh, we can just do inverse. Right, this is base 10, right? So don't do, oh, base 10, cancel, because base 10 and log cancel, base 10 and log cancel. This is also wrong. Okay, so you can only do it by have 1 and 1. Now, if I have a log that is log something, equal to log something, and then I can do base 10, and cancel them. That is okay. Okay, so this is kind of the introduction as to what you cannot do. And now we're going to into the steps on how you can solve. First is combine log expression on one side. If you have log expression, you want to combine them so you have one log equal to one log or one log equal to a number. So you should have the whole things the whole thing simplify until you have, okay, so more space over here. Until you have one log equal to another log for step 1. What about you have 2 log on one side, just like what I talked about earlier? Well, if you have 2 logs, then you combine them by using log properties of multiplication. And if your subtraction is you combine by log of dividing. And if there's a number outside, you move it in. So your goal is to get into this form of all log equal to a number. Okay, so these are cleaning up and rewriting to make sure you do that. Then you do exponent on both sides. So for example, if this is base b and this is base b and base b, then you do b to the something to cancel the log, solve for the unknown. Lastly, you always want to check for extraneous solution. This is a always. It's not just for checking answer, because when you do the exponent, sometimes extraneous solution shows up. So let's do the example after a lot of introduction. So I'm going to solve log 3x plus 1 equal to log 5x. So there's no base here. That means it's log 10, right? So by default, it's common log 10. So to cancel, I have one log equal to one log, so I don't have to do any cleanup. So I'm going to do, so I'm going to rewrite it. Log base 10, 3x plus 1 equal to log base 10. So it is easier for you to see that it is base 10 on both sides. Now you do base 10 to the power of this, that cancel, right? So we would have 3x plus 1 equal to 5x. And then minus 3x on both sides. This has become a linear equation. 1 equal to 2x. And then divided by 2, x is equal to 1/2. So that's the solving part. This is step 2. Step 3, you always want to check solution, check answer. Check x is equal to 1/2 if it's right or not. So you go back to the beginning. Log base 10, 3x plus 1 on the left-hand side. This is log base 10, 5x. Put in 1/2 here will be log 3/2 plus 1. That is log 5/2. And this side is also log 5/2. They're the same, yes. So this is the solution. Okay. This second one, I want to do a little more space. I see some log, 2 log on this side, so this is not ready for doing base 3, 3 to the exponent. So don't do exponent if you have 2 log. So I'm going to combine it by using log property of multiplying, because this is adding, so I can do multiply. And this is now base 3. I think this is wrong. That's 24. Probably a typo here. Oops, sorry. Just want to delete this. Well, delete that first. And then just delete it. Okay, so just 124. So then we would do, so now we have 1 log and 1 log. So I'm going to add the base, out the base 3 of exponent, base 3 of exponent. It'll cancel them, right? So I would have x times x plus 2 equal to 24. X squared plus 2x equal to plus 2x equal to 24. X squared plus 2x minus 24 equal to 0. Do diamond. Negative 24 for multiply, add for 2, so it'll be 6, 4. I want add to 2, so it'll be x plus 6, x minus 4 equal to 0. X equal to negative 6, x equal to 4 after you split them, right? So now we always check solution, check answer. First of all, check x equal to 6, negative 6 first. Come back to the really beginning. Log base 3, negative 6. Oh, there's a problem. You cannot do log base negative 6 because domain of any log function is not possible. So it's undefined. Then you might say, Ms. Chen, if you multiply, maybe it works. No, we check for the first one. So undefined, not a solution, not working. So we check x equal to 4. Hopefully this would work. If none of them work, you say no solution. Log 4 plus log base 3, 4 plus log base 3, 4 plus 2, log 6. So that would be log base 3, 24. And this side is log base 3, 24, they're equal. Okay, so this is a solution. So cancel this one, but x, because that is an extraneous. It's not because you make an error, because when you do the exponent, sometimes some extra solution will comes up. Another one would be if I have 2 things on one side, but they're dividing. So dividing means I can use the log property of rewriting x minus 2 over x when divided equal to ln 54. Now there's one log, I can do the exponent e to the power of ln, they cancel the inverse function. So x minus 2 over x is equal to 54. Solve this equation, we multiply both sides by by x. So that, and also we have to make sure that x cannot be 0, right? Then we would do, this would be x minus 2 equal to 54x. Because to distribute it, x minus 2 divided by x times x is no more. Then I would do then I do minus x on both sides. I want to isolate minus x. So negative 2 is equal to 53x. X is equal to negative 2 over 53. So this is the solution, but let's check answer. Let's check x equal to negative 2 over 53. In the left-hand side, I have ln negative 2 over 53 minus 2, also issue undefined, right? You can do a negative, right? You can do a negative and then minus 2 is still a negative, it's undefined, so no solution. Although, yeah, and when you plug in here, that's also a negative, that's also undefined. So the whole thing is no solution. Let's do one where we have a number on the other side instead of log. So I on the left hand side still see 2 log. I don't want it. So combine them by log property. So it'll be log 2x. So there's no base. It means base 10. Okay. 2x times x minus 5 equal to 2. This side has nothing. So I cannot do 10 to power. I can still do 10 to the power because I want to cancel this 10. 10 to the power, 10 to the power, but this would be 10 to the power 2, actually 10 to the power 2. So after I cancel this, I have 2x times x minus 5 equal to 100. Okay, so then 2x squared minus 10x equal to 100 because I'm going to do distribute. Then I can say, well, they're all divided by 2, so I'm going to divide by 2 first, make it easier. So be x squared minus 5x equal to 50. So I'm going to solve quadratic by subtract 50 on both sides. It will be x squared minus 5x subtract 50 equal to 0. Because when you have x squared and x term, you can only do, did I do that? Yeah, so it's just like this. You have x squared and x on both sides. You can do square root. The things you can do is factor. So use diamond. What two numbers when they multiply they're negative 50, when they add they're negative 5, is 10 and 5. Oh, I want negative first, so with negative 10. X minus 10, x plus 5. So it would be x is equal to 10, x is equal to negative 5. But I need to check answer. Okay. Oh, too big. Because I have 2 to check. So I'm going to write check answer on this side. X is equal to 10. Oh, I have to do log 2x plus log x minus 10. That would be log 2x 20 plus log x minus 5. 10 minus 5 is 5. So that is equal to log 100. That's equal to 2. So this is equal to 2. So that's correct. X equal to 10 is right. So then we will check x equal to negative 5. We can tell that it is not going to work because log 2x being equal to log negative 10. We have no negative, no, undefined. So the solution, this is an extraneous solution. Extraneous solution. So the only solution is x equal to 10. So that's the idea of solving like this complex log log equation. And remember, just like in chapter 4.3, if this is a really, really simple log equation, you just do a rewrite. Okay. If you are to like extra example, if someone say log 4 and then x is equal to 16, so no, not 16, that's too big. Log 3, right? So like then you can just do rewrite. You say, okay, that is equal to 4 to the 3 equal to x, and you're done. Okay, so the simple one, you don't have to do exponent or something. You can just do rewriting, although you can do exponent also. Then the last thing is to solve any of those by calculator. So I want to teach you how to solve by calculator. Maybe I'll do another video. So I'll end this in that video. The third video will talk about how to solve exponential as well as log equation. Oh, well, actually mostly exponential by calculator.